Welcome everyone. In this video I am going to talk about the solution of differential equation of first order and higher degree, and in this I am going to talk about the third type, that is those equations which are solvable for x. The first two types, solvable for p and solvable for y, I already have discussed in my two previous videos. So what is the process here? Let me explain you the process first. So given any differential equation, first you try to solve it for x. When I say you have to solve it for x, means you have to write x in terms of y and p, and then in the next step you differentiate this with respect to y, right? So you differentiate this d by dy of fxp, and you do the calculation. In the end you try to, and here for dx by dy you replace it by 1 by p. Then you solve it for getting a differential equation in terms of dp by dy. So you get a differential equation in terms of dp by dy. You solve this differential equation. So whatever solution you get in terms of y and p, you call that equation number 2. The equation number 1 is the original equation, and from the original equation and the equation that you get after solving the differential equation in terms of dp by dy, you eliminate p, and after you eliminate p, what you get is the solution. Sometimes it may not be possible to eliminate p, so you write both equation 1 and 2 together and say that both of them are the solution, where p is the parameter. So these things might not have made much sense to you, so to make it more clear, I am going to solve two simple problems. You have to watch it till the very end to be very clear about the process. Okay, so let's start with this particular problem. So in the first observation, it looks like that it has been written as y is equal to something, but it is not solved for y because you have both px and also y in the right hand side. And here it is a quadratic in y, so it is difficult to solve it for y. Here it is a cubic in p, so it is difficult to solve it for p, but it is very easy to solve it for x, because I can simply write y is x is equal to y minus y square p cube by 2p, right? And then what we do in the next step, I am going to write it horizontally, or let me write vertically, no problem. So in the next step, what I am going to do, I am going to differentiate it with respect to y. So I will write dx by dy, and here I write d by dy of y minus y square p cube divided by 2p. What we do next, we replace dx by dy by 1 by p. Here I write 2p d by dy of y minus y square p cube minus y square p cube d by dy of 2p, and in the whole we have to divide by 4p square. I have used u by v formula. I hope you understand, right? Now I do the cross multiplication, 4p square and 1 by p, it will become 4p. Here I will get 2p. Dy by dy is equal to 1 minus, here product rule I have to apply, so y square into 3p square dp by dy minus, if I differentiate it, I will get 2y p cube, and then 2 times y minus y square p cube into dp by dy. Now I have to simplify this. So how can I simplify? I can start here. So just for your convenience, I am going to copy everything here in this second page. So here we have this expression. So let's simplify it now. So we have 4p, and then we have 2p minus, if you multiply you will get 6 p cube y square dp by dy minus 2y p to the power 4 minus 2y dp by dy plus 2 y square p cube dp by dy. So I have multiplied everything. Now I have to recollect the terms, so I am going to bring all the things in the left hand side. So here we have 4p, here we have 2p. So 4p minus 2p is equal to 2p. Here we have minus 6 p cube y square, and we have plus 2y square p cube dp by dy. So if I take this term and this term, I will get minus 4. So if I bring it in the left hand side, I will get plus 4 p cube y square dp by dy, and then we have these two terms, so I write plus 2y p to the power 4 plus 2y dp by dy is equal to 0. Now what we can do, we can collect the terms. So 2p plus 2y dp by dy. I have taken the first term and the last term, and from this I can take 2 common, I can take y common, I can take p cube common. So if I take this, I will just get 2p here, and here I have taken 2 common, so I will get 2. P cube I have taken common, so I will get y dp by dy. So this is something that you can very easily do, and after this I can take 2p plus 2y dp by dy into 1 plus 2y p cube, that is equal to 0. Now as I have told you that I am trying to solve the differential equation to get an equation in terms of dp by dy. So here I have got two factors. So this factor that I have got, if you have watched my previous video where I have discussed the equation solvable for y, you may remember that we ignore this one. What we do, we ignore this term. Now you may ask me that why you are ignoring this term, because we are solving the differential equation to get the general solution. So if I take this term and so let me just spend some time on this. Suppose I take 1 plus 2y p cube is equal to 0, and I call this equation number 2, and we have this original equation, that is equation number 1. So from equation 1 and 2, if I eliminate p, what I will get is the singular solution. But since we are not looking for singular solution, we are looking for general solution, I am going to ignore this part. So I hope you got what is the idea, that we have to take that factor or that term in the solution here, which is having dp by dy term, right? So here I will write now. So this implies that 2p plus 2y dp by dy is equal to 0. For our convenience, I can take 2 common and cancel from both sides. So we get p plus dp by dy is equal to 0. Yeah, here we have y also. Now moving to the next page, I am trying to solve it by variable separable method. So the equation that I have got is p plus y dp by dy. So p plus y dp by dy is equal to 0, which can be written as p is equal to minus y dp by dy, which can further be written as dp by p is equal to minus dy by y. Integrating both sides, I get ln p is equal to minus ln y plus ln c. So ln p plus ln y is equal to ln c. So ln py is equal to ln c. So from this I get py is equal to c, and this is my equation number 2. So I have the first equation, that is y is equal to 2px, y is equal to 2px plus y square p cube. This is equation number 1. So after this, what we have to do, we have to look at both equation 1 and 2, and if it is possible to eliminate p from both the equation, we eliminate p. If it is not possible, then what we do, we write equation 1 and equation 2 together. Let me explain what I am saying. That suppose I am not able to eliminate, so I will write py is equal to c, that is equation 2, and I will say that these two are the solution where p is the parameter. So this is the process, but here you can clearly see that it is not very difficult to eliminate. So in spite of writing the solution like this, what I am going to do, I am not going to write it like this, because we can easily eliminate p. So I am going to eliminate p from this equation. So how to eliminate p? Since py is equal to c, so this will give me p is equal to c by y, and I will substitute c by y in the equation 1. So I will get 2p into c by y plus y square, and p cube will be equal to c cube y cube. So y square and y cube cancel. Now we have y, so we can multiply both sides. I will get y square is equal to 2. I think I made a mistake here. Here I have replaced for p, so it is not x, because I have to write 2 x, and for p I have written c by y, right? So what I will get is I have to multiply by y, so I will get 2cx. Just a minute. The equation is y is equal to 2px plus y square p cube. So here I have written 2x, and for p I have written c by y. Now yeah, so if I multiply, I am getting 2cx plus c cube. So this is my final answer. I hope you got the solution. The idea is that if it is possible to eliminate p, just eliminate. Otherwise you can write both the equations 1 and 2 together and say that p is the parameter. Okay. Now to make more sense, I am going to take another problem. It is also slightly time consuming, so just listen very carefully, and you can also try to solve it together with me. So when you look at this equation, you realize that here it is a cubic equation in p, quadratic in y, but it is just linear in x. So it is very easy to solve it for x. So what I can write x is equal to p cube plus 8y square divided by 4yp. I hope you will agree. Yes or no? Because if I have to solve it for x, it can be easily done. Now I have to differentiate it with respect to y. So I am going to differentiate it with respect to y. So dx by dy is equal to d by dy of p cube plus 8y square divided by 4yp. And what we do, we replace dx by dy by 1 by p. Yes, and here we can take we can apply u by v formula, or even I can take this 1 by 4 term outside so that it looks simpler. So the denominator becomes yp because 1 by 4 constant I have taken outside. So I will write yp d by dy of p cube plus 8y square and minus p cube plus 8y square d by dy of yp, and the whole thing will be divided by what? It will be divided by y square p square. So let's do the simplification now. Here we have 4 into y square p square. I can take it in the left hand side by cross multiplication. So it will become 4 y square p square by p, and here we have yp. We have to differentiate this. So p cube will give me 3p square dp by dy, and 8y square will give me 8 into 2 16y. Yes or no? And minus here I will have p cube plus 8y square and d by dy of yp, so y dp by dy and plus p dy by dy will become 1. So what I am going to do, I am going to copy everything in the next page so that it is easier for us to see, right? So just give me a moment. So I have copied all the term from the previous page. Here you can see 4y square p square, so pp will cancel. I will get 4 y square p here, and all other terms like yp into this minus this I have copied here. Now I have to do the simplification. So I have 4 y square p. If I multiply, I will get 3 and p to the power 3y dp by dy. 3p square into p, so yeah, and here I will get 16 y square p, and here what I will get minus p cube y dp by dy, the first term. Now minus 8 y cube dp by dy minus p into p cube p to the power 4 and minus 8 y square p. Okay, now let us do the simplification. So first term we have, let us look at this term first, 4 y square p, and here we have 16 y square p and minus 8 y square p. So 16 minus 8 is 8, right? And if I bring it in the left hand side, 4 minus 8 will become minus 4y square p, right? and then we have minus p to the power 4, so I bring this term minus p to the power 4. So I am done with these terms. Now we have 3p cube y, and here we have minus p cube y, so it will become 2p cube y. If I bring it in the left hand side, I will have minus 2p cube y dp by dy. So I am done with this term and this term as well. So this just one more is left. So plus 8y cube dp by dy is equal to 0. Now I have to solve it for dp by dy. So what can be done? From this, if I take p common, I will get p cube minus 4y square. I hope it is correct. P cube and minus 4y square. And from these two, what I can take common? I can take minus 2 y can be taken common, and minus 2y dp by dy can be taken common. So in the bracket I will get minus 2y I already have taken common, so I will get p cube, and here it is plus, so it will become minus, and it will become 4y square. I hope it is correct. You can verify minus minus plus, so 2y into 4y cube, 8y cube. Yeah. Now I can clearly see that I will get p minus 2y dp by dy into p cube minus 4y square is equal to 0. And as you have seen in the previous problem, I am trying to solve it for dp by dy. So I will take that factor which will give us dp by dy, and I will ignore this because this will give me the singular solution. So by ignoring the second, I can write y is equal to, sorry, p minus, let me write one more step. So I write p minus 2y dp by dy, 2y dp by dy is equal to 0, which I can write as p is equal to 2y dp by dy. Moving to the next page, I have to separate the variables, so I write this implies dp by p here will be equal to dp by p is equal to dy by 2y. So I write dy by 2y. I hope you agree to this. Or we can also write here 2 dp, whatever you want to write. It is better if you allow me to write. Let me just make one correction. I write 2 in this side because the calculation will be easier in that case. So I again repeat, you can see here we have 2 dp by p and dy by y. So I have separated the variable. Now I am going to integrate both sides. So I will get 2 integration with respect to if I integrate, ln dp by p will be equal to ln p, and dy by y will be equal to ln y. We have to add the constant of integration, that is ln c. So what I get? I get ln p square by y if I bring it in the left hand side, and this is equal to ln c. So p square y is equal to c, right? So this is my equation number 2. Now what is the equation number 1? Equation number 1 is p cube minus 4. Let me write p cube, sorry, it is not y cube, it is p cube. So equation number 1 is p cube minus 4xyp plus 8y square is equal to 0. And equation number 2 I have got is p square by y is equal to c. So can we eliminate p from this? If we try, we can eliminate. So I can write from this, I can write p square is equal to cy. So from this I will get p is equal to under root cy, right? So here I write in this was equation number 1. So in place of p I write this under root cy. So I will get under root cy to the power 3 minus 4xy into under root cy plus 8y square is equal to 0, and this is your final answer. So I hope you are clear about the process of solving the differential equation, where it is easier to solve it for x. So what is the major difference? The first one is that when you solve it for y, you differentiate it with respect to x and you replace dy by dx by p. But when you solve it for x, you differentiate this with respect to y and you replace dx by dy by 1 by p. Some students always have this confusion that sometimes it is easier to solve for both x and y well. Then means sometimes what I'm saying, that in some of the problems it may occur that you can solve it for x also, you can solve it for y also. Which one should I prefer? So for that there is no ready-made answer, because that will depend upon on the nature of the problem, that which one will make the computation easier. So beforehand you can't anticipate. So only thing is that try to solve it for y. If you are able to solve it easily, then fine. Otherwise, if you are not able to, then try it for x. So this is the process. Personally, what I do when I look at any problem, I try to solve it for p. If not possible, then I think of solving it for y. If not possible, then I think of solving it for x, and process remains very clear. Now in the next video I am going to talk about the Claret's equation, and in that video I will also talk about what do you mean by the singular solution, because in the last two videos I highlighted this term singular solution, but I have not talked about that. So in the next video I will talk about that as well. For this video, that is all. Thanks for watching. In case if you are new to the channel, please subscribe the channel, like the video, and share it widely with all your friends who can get benefited from this kind of good quality video. Have a great day.